Okay, everybody, let's move on to the next lesson. There will be time tomorrow. If you have questions from that first lesson, we can go over them. As we work through this second lesson today, I am going to probably cut out some of the examples. I don't think we need to do all of them. So we're looking on page 10 of your unit handout. This is lesson 4.3. We're finding trigonometric ratios. And in the past, when we find trigonometric ratios, we would be talking about things like opposite and adjacent and hypotenuse, because if you want to find the value of the trigonometric ratio, which we call sine, you would take the opposite side of a triangle divided by the hypotenuse. Well, this is going to be a little bit different. To begin with, it turns out that there are 6 trigonometric ratios. So this is something that has been kept from you up until this point. You've always talked about sine, cosine, and tangent, but in fact, there are 6 that we're going to have to contend with. I can tell you right now what they're called: sine, cosine, tangent, cosecant, secant, and cotangent are the names of the other 3. So we're going to write the 6 trigonometric ratios for a point that is the intersection of a terminal arm with the unit circle. We're also going to use a calculator to understand how to calculate approximate decimal values of these trigonometric ratios. You already know how to find sine, cosine, and tangent, but we have to talk about how to find the other 3, and there's no button on your calculator for any of the other 3. We're going to be determining exact values of trigonometric ratios for rotation angles that are on that unit circle, that are identified on that unit circle. And we already know how to do this, but we're just going to practice a bit more. Determine the trigonometric ratios for a point if it's not on the unit circle. So the very first bullet here, determining the trigonometric ratios of a point on the unit circle, is identical to the fourth bullet here. It's just that these points would be not on the unit circle. And then finally, if I give you one of the 5 trigonometric ratios and I give you enough information, what are the other 5 trigonometric ratios? So I give you one of 6, you have to be able to find the other 5. And this looks like a boatload of information, but really the principles behind all of it are fairly straightforward. I do need to review something from Math 20-1 though. In Math 20-1, you abandon the idea of opposite, adjacent, and hypotenuse, and you use instead x, y, and r. So rather than talking about a hypotenuse, what we talk about instead is the length of the arm to the point, and that length is called r. It's the radius of the circle. Rather than talking about opposite, and you can see by this diagram that opposite is the vertical component, rather than talking about opposite, we use y, and rather than talking about adjacent, we use x. Not a very good triangle, but you get the idea. So cosine is normally adjacent over hypotenuse, but we don't have an adjacent. We have x, and we don't have a hypotenuse. We have r. You need to know these 3 definitions from Math 20-1. And in Math 20-1, we decide to give them to you on a formula sheet. These are not on your 30-1 formula sheet, so you need to know these. Tangent is y over x, sine is y over r, and cosine is x over r. Memorize them, know them. By the way, most people will have no difficulty knowing that tangent is y over x, but sometimes people will confuse cosine and sine. If you put the word cosine in an alphabetical list with sine, cosine comes first. If you put x in an alphabetical list with y, x comes first. Bottom line, you need to figure out how to know those definitions. Now, here are the 3 other trigonometric ratios. Sine, cosine, and tangent are called primary trigonometric ratios. These 3 are called reciprocal trigonometric ratios. Secant of an angle is defined as the reciprocal of cosine of the angle. And there's no way to abbreviate that when we say it. When I say this, I say secant theta. I don't go sec theta. It's secant theta. Cosecant theta is abbreviated when you write it CSC, but we don't abbreviate it when we say it. We say cosecant theta. And cosecant is the reciprocal of sine. Cotangent theta is the reciprocal of tangent, and we do abbreviate that. When we say it, I will very often say cotan theta rather than cotangent. These you don't need to memorize. They are on your formula sheet, but I want to point something out to you that it may be obvious to some of you and it may not be. I'm just going to pick on secant. Secant of theta is equal to 1 over cosine of theta. And if I cross multiply, I can get secant theta multiplied by cosine theta equals 1. And if I divide by secant theta, I get cos theta equals 1 over secant theta. And I'm making a point here. Secant is equal to the reciprocal of cosine, and cosine is equal to the reciprocal of secant. They are reciprocals of each other. Okay. Now, if it's the case that cosine of theta is x over r, and you know that from Math 20-1, and you know that secant of theta is the reciprocal of cosine, then we just take that x over r and we say secant of theta is r over x. If sine is y over r, but cosecant is the reciprocal of sine, then the reciprocal of y over r is r over y. Tangent and cotangent are reciprocals. So if tangent is y over x, then cotangent is x over y. So you need to know these. You know, when I say you need to know cosine is x over r, sine of theta is y over r, tan of theta is y over x, you also need to know those other three as well. And there's no easy way for me to say this. You just need to know them. If you don't know them, everything in the rest of all the trigonometry in this course falls to pieces. So I do want to point out to you that these are the 6 trig ratios that you're looking at here. But if the point that we're talking about is on the unit circle, then r is 1. So if it's on the unit circle, then all of those r's become 1, and cosine is not x over r, it's x over 1, which is just x. The only caution I would have about memorizing this second list is I don't think you need to. If you know this first list and it is on the unit circle, just change r to 1 and you will have cosine. Change r to 1 and you will have secant. Now the rest of the lesson is all examples. All examples dealing with these definitions and what we learned about the unit circle. So determine the exact value of the sine of pi over 3. Well, this is what should go on in your head. You say to yourself that I need to locate pi over 3, and you draw it approximately where pi over 3 is. Then you imagine a circle that's a unit circle. This is 1 and this is 1, and you determine the coordinates of that point. Now, I do understand that you can look at your unit circle that we completed a half hour ago, and you can read off of your unit circle that this is 1/2 and this is root 3 over 2. I understand you can look at it, but you don't have that for an exam. So what you do instead is you say, this point is not the point where we have root 2 over 2 and root 2 over 2. It's the point where we have a half and root 3 over 2. And you ask yourself, is this a half or is this a half? And this is a half. You can see it's a half because from here to here is 1. So bottom line, in the 2 minutes it took for me to explain this, it would take me probably 20 seconds or 10 seconds to know that the answer to this question is root 3 over 2. It's the y coordinate on the unit circle. Sine is y over r, and r is 1, so we just look at the y coordinate. What about cosecant of negative 5 pi over 4? So we need to locate negative 5 pi over 4 first. Here's 0 pi over 4. Here is negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4 is here. This is negative 5 pi over 4. Cosecant of an angle is equal to the reciprocal of cosine. So you need to listen carefully, and you may have to write a couple things down, but sorry, cosecant is the reciprocal of sine. Cosecant of theta is the reciprocal of sine, and sine is y over r, so cosecant is r over y. But if we're looking at the unit circle, r is 1. So we need to know the y coordinate of this point so we can write out what 1 over it is. Well, the y coordinate is root 2 over 2. I'm going under the assumption here that you know the coordinates of that point are negative root 2 over 2, comma, root 2 over 2. Personally, I would go with this version, although it doesn't matter, because if I take the reciprocal of 1 over root 2, this is y, 1 over y is the reciprocal of it, I get a nice number. I get cosecant of the negative 5 pi over 4 equals the reciprocal of this number, which is root 2. I'm going to do one more and then see if there are questions. Let's do tangent of negative 11 pi over 6. So the first thing you do, and you can look at your unit circle, but the first thing I would do is count off negative 11 pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the location of negative 11 pi over 6. And all I'm writing here, everybody, for all of these, this is all scrap paper. It's me thinking. The coordinates here are 1/2 comma root 3 over 2 or root 3 over 2 comma 1/2 because it's one of those 30-degree angles. I can see that if this is 1, this sure as shooting is not 1/2. The y coordinate will be 1/2. The x coordinate will be root 3 over 2. Tangent is y over x. We need to know tangent is y over x. So I have to take the y coordinate over the x coordinate. And I'm going to simplify that by multiplying the top and the bottom by 2. The 2's cancel on the top, the 2's cancel on the bottom, and you get 1 over root 3. It probably will not come as a big shock to you that that's root 3 over 3. If 1 over root 2 is the same as root 2 over 2. 1 over root 3 is the same as root 3 over 3. Cosecant of 3 pi over 2. You need to locate 3 pi over 2 first. 3 pi over 2 is at the bottom. And you need to know the coordinates there are 0, comma, negative 1. Then you need to say that cosecant is the reciprocal of sine, and sine is the y coordinate, which means cosecant is the reciprocal of the y coordinate, which is 1 over negative 1, which is negative 1. So cosecant of 3 pi over 2 is negative 1. I'm going to pause there for a minute. Does anybody have any questions with A through D?
I have a question.
Go ahead, Aiden.
For B,
Yep.
you did the inverse of 1 over root 2. Is there a way to do it as root 2 over 2?
Certainly. So experience tells me if I take the reciprocal of this thing that I've highlighted, experience tells me I get a nicer number to look at. Root 2 is a pretty easy number to look at on the eyes. Now, when I take this and I take the reciprocal of it, I'm going to end up with, instead of root 2, which is what I got when I took the reciprocal of this, I'm going to end up with 2 over root 2, which is a very clunky number. And in Math 20, you're taught that you want to rationalize anything with a denominator that has a radical. And if I do that, I multiply across the top, Aiden, and get 2 root 2. And when I multiply across the bottom, root 2 times root 2 is 2. So I still end up with root 2 because those 2 2's cancel. That's a lot of 2's. So you still end up with root 2. Is this any more correct than this? No. But if it were a multiple choice exam, you might see root 2 and not 2 over root 2. Did I satisfactorily answer your question?
Yeah.
Okay, good. And do me a favor, Aiden, and just mute your mic again. Any other questions before we go on? Okay, so as I go through some of these now, you're just going to want your unit circle right in front of you because I'm not going to spend a lot of time here. With 240 degrees, it is here, and the coordinates are negative 1/2, comma, root 3 over 2. I mean, I said 180 plus 60 gives me 240, so I know those coordinates. What is the cosine? It's the x coordinate, which is negative 1/2. What about secant of 45? Negative 45. Well, negative 45 is down here, which is at, well, we have that choice, just like Aiden and I were discussing. I'm going to go with 1 over root 2, comma, negative 1 over root 2, because looking ahead, secant is the reciprocal of cosine, which will be 1 over the x coordinate, because cosine is x. By the way, when I write 1 over x, that's the same as taking x and flipping it over. So if I take cosine to be 1 over root 2, which I do, the reciprocal is root 2. Had we chosen root 2 over 2, we would get for a reciprocal 2 over root 2, but it's the same thing. All right, we don't need to do another one. We're going to skip over tangent and cotangent. Let's learn how to use our calculator. If I ask you to determine cotangent of 7 pi over 8, you can't do it. I mean, let's jump ahead to C. You should be able to figure out C. You simply take the sine of 35 degrees. and I'm obviously in the wrong mode. I'm go into degree mode. So you get 0.574 for C. You do know how to do D, but I want to point something out to you. There's no degree symbol on the number, which means we have to be in radian mode for D. So what D says is cosine of 20 radians, not degrees. So I'm in radian mode now. So you get 0.408. Now, how do I determine cotangent? See, I don't have a cotangent button, but I know that cotangent is the reciprocal of tangent. So there's two things I can do here. I can find the tangent of 7 pi divided by 8, and then take the reciprocal of it. Or I could just say it's 1 divided by tan of 7 pi over 8. But in either case, I get, that's weird, I get negative 2.4 something. So if I want secant, I guess I can close this now. If I want secant, I have to know that secant is the reciprocal of cosine. So I take the reciprocal, which means 1 over cosine of negative 5 pi over 11. And that's how you use your calculator to find reciprocal trig ratios. So I'm going to pause there. Does anybody have any questions in getting any of those answers? Okay. We still have some examples to go here, so I'm going to ask everybody to take a deep breath because we're going to power through this, but I'm going to change my schedule. And what that means is I'm going to plan on tomorrow. We will probably only do one lesson tomorrow. So the first part of tomorrow's afternoon will be spent working on and going over a lot of the problems from this lesson. If I rush through this lesson right now to give you enough time to work on the problems, it will be a crappy lesson, okay? I need to go slow here so that you get the idea, and then I will worry later about the homework. We'll worry about that in the end. What will probably happen is I will tell you, okay, so for tomorrow, get these couple of questions done, and then we're going to continue working on them tomorrow, okay? But I don't want to rush through this and damage what could be really good understanding on your part. So we're looking now at example 3. We have a point that's on the terminal arm of a rotation angle, and the coordinates of the point are negative 5 13ths, comma 12 13ths. Show that that point is on the unit circle. Well, if a point is on the unit circle from the lesson before this, x squared plus y squared has to equal 1. So we can take negative 5 over 13 squared and add 12 over 13 squared and see what we get. And I don't want you just to use your calculator here. When I square negative 5, I get 25. When I square 13, I get 169. When I square 12, I get 144. And when I square 13, I get 169. And you can certainly use your calculator to confirm those squares. When I add them together, I end up with 25 over 144, 25 plus 144 over 169. Well, that's 169 over 169. So that's 1. It's on the unit circle. If we know it's on the unit circle and you're asked to determine the value of these 6 ratios, if it's on the unit circle, cosine is the x coordinate, Sine is the y coordinate. Tangent is y over x. If it's on the unit circle, secant would be 1 over x, because secant is the reciprocal of the x coordinate on the unit circle. Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. If sine is y, cosecant is 1 over y. Cotangent is the reciprocal of tangent, which should be x over y. So really, in this question, all we have to do for the cosine is write the x coordinate. Cosine of the angle, I better just look, is negative 5/13. It's the x coordinate. Sine of the angle is 12/13. It's the y coordinate. This is what I meant earlier when I said there's not a lot of difficult math involved in this, there's just a lot of details and examples. What would the secant of the angle be? Well, secant of the angle is going to be the reciprocal of cosine, so we flip that number over. Now, I prefer to put the negative on the top. Even though it was with the 5, I'm putting it on the top anyway when I flip it over. Cosecant is the reciprocal of sine, which means I take sine, 12 over 13, and I flip it over. Now, tangent is going to require a bit of work because we have to take the y coordinate, 12/13, divide by the x coordinate, negative 5/13, and that gives us a complex fraction. What do I mean by that? I mean it's got numerators and denominators within the numerators and denominators. So I think the quickest course of action is to multiply top and bottom by 13. These cancel, so tangent of theta is equal to 12 over negative 5, which is negative 12/5. Again, I don't care whether x owned the negative or whether the negative was owned by y. I always put it on the top. That means cotangent of theta is the reciprocal of that, which would be negative 5/12. And this is such an important question, the one we just did, that I want to pause again and see if anybody has any questions. All right, seeing none, let's take a look at example 4. The first thing I want to do, and this might be good because I think some of you might be getting weary, this is a long, long time to be at this, is I want you to think about whether this point is on the unit circle. One of the ways to answer that question is to remember that x squared plus y squared equals 1. So ask yourself, what do you get if you square negative 3 and square 8? Well, how many of you see you're not going to get 1? How are you going to get 1 out of that? These numbers will be 9 and 64. The other thing you can do, and it's what I did, is here's my unit circle. The radius of this is 1. And what that means is that this is 1 and this is 1. Now the point is negative 3 comma 8. Well, where is negative 3 comma 8? It's way over here someplace. It's up here somewhere. It's not even close to being on the unit circle. So, what's the point here? In the previous question, we wrote x for cosine and y for sine because it was on the unit circle. This is not on the unit circle, so we have to do this. Tangent is still y over x. What does that mean? It means secant will be r over x, the reciprocal of cosine. Cosecant will be r over y, the reciprocal of sine. Cotangent will be x over y, the reciprocal of tangent. We know x. We know y. We don't know r. So we're going to find r by going back to the first lesson today, which said the equation of a circle is x squared plus y squared equals r squared. We can use this relationship to find out what r is. X was -3, y was 8. Can I get a couple people to, well, you should all be typing this, you should all be calculating it, but I want people to confirm that you get 73. So I get a couple people to type in chat whether you get 73 or not. Other people could just tell me verbally. Okay, so it is 73, good. And I wrote 72 for some reason. It's 73, which means r is root 73. No plus or minus. R is a length of the radius. It's a positive number. So now, this is really simple, but I feel as though I'm packing in a lot of information. What is cosine of theta going to be? -3 over root 73. X over r. What is sine going to be? 8 over root 73. What is tan going to be? Tangent of theta will be y over x, which will be 8 over -3. But again, I just prefer to put that negative on the top. Aiden, because we had this conversation earlier about rationalizing, but everybody as well, you don't have to rationalize this and this. You certainly could, but it's not a requirement. To find secant, cosecant, and cotangent, we just flip these guys over. Secant of theta would be -root 73 over 3. Cosecant of theta would be root 73 over 8. Cotangent theta would be -3 over 8. So in example 3, once we determined that it was on the unit circle, we were able to just say, oh, okay, cosine is x, sine is y, tan is y over x. Because r is 1. In question 4, we need to include that r in our calculation because r is not 1. But once you know sine and cosine and tangent, you just flip them over to find the other 3. Any questions with number 4? Okay, again, we're moving forward here. This is too important to rush through. So we have 2 more examples, and we will get through both of them before the 3:30 deadline. Angle B lies in quadrant 2, and cotangent of theta is -2/3. Now, if you've had me as a math teacher in Math 20-1, you might remember that I absolutely hate this. I hate that negative right in front of the whole thing. Mathematically, it's confusing. I mean, it means the whole thing's negative. But in this particular case, cotangent of theta, I would like everybody to think for a second about how cotangent of theta is calculated using x, y, and r. And hopefully you say, well, tangent is y over x, which means cotangent is x over y. So x divided by y gives you negative 2/3. But negative 2/3 is the same as negative 2/3, which is the same as 2/3. These three quantities are all equal. So the question becomes, where do I put the negative? Do I put it on the top with the x, or do I put it on the bottom with the y? And since the angle is in quadrant 2, it's going to go with the x. Because in quadrant 2, which is here, x is negative. What that tells us is that x is negative 2 and y is 3. To answer this question now, it has turned into the same situation that we had in example 4. What we are missing is r. So I would like everybody to calculate right now the exact value of r using x squared plus y squared equals r squared. You're going to take negative 2 quantity squared, which means in brackets, and add 3 squared So Emily, you typed x is negative because it's in quadrant 2, and the answer to that is yes. We know that if we have negative 2/3, the negative must belong with the x or must belong with the y. But because the angle is in quadrant 2, we were told that in quadrant 2, and you can pick any point you want. You can pick this point here and tell me what you think the coordinates are. It will be a negative x coordinate and a positive y coordinate. So the reason x is negative is because it's in quadrant 2. Had I said it was in quadrant 4, then y would have been negative. And we'll talk more about this later, but there's no way this could be in quadrant 1 or quadrant 3. Because if it's in quadrant 1, they're both positive, so cotangent would be positive. And if it's in quadrant 3, they're both negative, which means x over y would be positive. But I don't want to get too far ahead of myself. Can you guys confirm to me that you get root 13? Okay, good. Look, I'm not even going to write down, thank you. I'm not even going to write down that cosine is x over r. I'm simply going to put negative 2 over root 13. You should know that sine is y over r. Well, that would be 3 over root 13. You should know tangent is y over x, or just take cotangent and flip it over. And secant is the reciprocal of cos. Cosecant is the reciprocal of sine. Any questions with example 5? Okay. Final example, I believe. Yep. Final example is you were told secant is 7 over 5 and cotangent is negative. What is cosecant? And when you first look at this question, your brain starts to just, like the left side of your brain looks at the right side of your brain and says, I want to take a nap. Because it's like you don't even know where to begin. Well, you cut to the chase and you say that cosecant of theta, which is what you want to find, let's see, Cosecant is the reciprocal of sine. Sine is y over r, which means cosecant is r over y. So what I've done is I've turned the question into something simpler that says I need to know y and I need to know r. Okay, we're getting there. Now what does this piece of information tell me? Well, secant of an angle, let's see. Secant is the reciprocal of cosine. And cosine is x over r, so secant must be r over x. But you're told that's 7 over 5. So what we can do is equate r with 7 and x with 5. So we know r is 7. Don't forget what's on the right side of the screen is what we are after. Cosecant of theta. So we know r, it's 7. We just have to find y. And we can find y by using x squared plus y squared equals r squared. Because we know x is 5. So I would like everybody please to calculate what y squared is. So I just want to know what 7 squared minus 5 squared is. I think it's 24, but I'm just doing that in my head and my head is weary. It is 24, good. So what we get for y squared is 24, which means y is, and at this level you must say plus or minus the root. Now you have to make a decision. Way back at the beginning of this afternoon, we had problems where you had to use plus or minus because the arm could be in two different locations. But we've also had situations where we exclude one of the positives or negatives. So let's talk about that. Let's simplify root 24, by the way. 24 is 4 times 6, which means y is equal to plus or minus 2 root 6. I'm doing a grade 10 mixed radical thing. Okay, y equals 2 root 6 versus y equals negative 2 root 6. Which is it? Okay, sometimes, and you've heard me say this before, sometimes in a question there is this kind of stuff that a lot of the time it's my parsley on the fish. It doesn't do a thing for the recipe. It doesn't change anything. But sometimes hidden in that detail is important information. Cotangent is negative. Okay, wait a minute. Cotangent is negative. Cotangent is x over y. If x over y is negative, then either x is positive and y is negative, in which case, if x is positive and y is negative, then it's in quadrant 4. Or if x over y is negative, maybe x is negative and y is positive. Maybe it's in quadrant 2. But if x over y is negative, it has to either be in quadrant 2 or 4. Why is it I know that it's in quadrant 2? Why is it I know that it's in quadrant 4? Because secant was positive. And if secant is positive, x must be positive. Because r is never negative. Man, that's got a lot to it. So since secant is positive, basically the angle must be in one of these two quadrants for secant to be positive. Since cotangent is negative, it must be in one of these two quadrants. So it has to be in quadrant 4. In the end, that tells you that y is in fact negative 2 root 6, which means cosecant is 7 over negative 2 root 6, or negative 7 over 2 root 6. So now I'm going to pause. Does anybody have any questions with that final example. You need to really do your best with this stuff that we're into now to pay very, very close attention to details. Positives and negatives and squaring and the unit circle numbers, all of that. So as I've been finishing this up, I've been trying to sort out what I'm going to do here to change my schedule, and I've decided that we will worry about gaining back the lost time later. I'll be able to find it somewhere. So you have an assignment here. What we're going to do, if you can feel free to do some of this for homework. In fact, I would recommend doing some of this. But for the at least the first 45 minutes tomorrow, we will be here together and you will be working on this and we will be going over questions. Okay, so the first 45 minutes of tomorrow is classwork. I know that seems weird, long distance, but that's what we're going to do. Then we're only going to do one lesson tomorrow.